Okay. So, those of you that are totally new will have never seen Canvas before unless you've seen it already in another class. And so when you log into Canvas, you should see whatever courses that you're taking. You know, yours will look different than mine, but you should see whatever courses that you're taking here, and you'll click on that block. So this is what the image looks like for this class, and we'll click on it. And this is what Canvas looks like. And here is where I had posted the incorrect video. But if you have not watched lecture 1, a lot of it I'm going over in this class anyway today, but you can skim through it towards the end and see if there's something that I don't go over. Today I'm going to actually go into the Mind Tap chapter 1, and that's what I lectured on in the 930 class. And so that will be posted. So, and so those of you that came in a few minutes late, and if you didn't catch that, even though we don't meet on Monday, I will record the lecture on YouTube, and you will still need to watch that because I'm not going to cover that same thing on Wednesday because then we won't have time for everything. So Monday, you need to pick some time between, it'll be posted by Tuesday morning. It might be Monday night, but before Wednesday class at 12:30, you need to watch that Monday lecture. So you can watch it whenever you are able to, just so it's before this lecture, or you won't understand, because I don't want to repeat everything that I taught on Monday, or we will be behind, okay? But I will answer questions if you watched the Monday lecture and there were things that you did not understand. Okay, you can watch it and email me questions, or first thing in class, if I forget to ask and you have a question about something that I covered in the Monday lecture, be sure and let me know. Okay, questions about that? Yes.
You can come in on Monday, right?
You can come in on Monday if you're free at 9:30 on Monday morning, and if there's not a seat, you can pull a chair in back there and still, because you have a laptop anyway. Okay, but as long as there's a seat, you're free to sit in the seat also. You can also, if you just want to be at home and you're available at 9:30, because I Zoom all of these, you can click on that Zoom link and you can come into class. And then if you have questions, you can turn on your mic and ask the question. It'll show me that your mic comes on, or we'll hear you up over the speaker when you say, hey, I had a question, okay? So you can be online at home and still be part of the Monday lecture. And I wanted to say that also because of my online students, some of them may like to do that because I have a whole nother section of about 26 students that are online. So at one time we may have 20 extra students in here. I will give them the option of the 1230 class too. So, all right. So that will always, that link that I'm talking about, that Zoom link is right here. So if you want to Zoom in to either my 9:30 a.m. Monday, Wednesday, or even if you are sick and you have to miss this class but you can do it from home, then you can Zoom into this class also. Probably be where there won't be anybody in class anymore, right? That's what most instructors are concerned about, so they don't give students that option. All right, so also I will activate this. It's not yet, but this YouTube link will be the playlist for all of this class videos that we're recording, okay? Let me go ahead and publish it because you can't see it until I publish it. Oh, I know why I don't have it published yet, because it's not the right link yet. Okay, these are different tutorial sites that you can use to learn Python. But we will be doing some Python in here, but Python is not what this class is really about. It's about learning logic. So it's about solving problems using pseudocode and flowcharts, which means that they can be used to code in any language. But then we're going to use a little Python because it's the easiest scripting language to learn. And you can, we're going to do a program today called Hello World. Who's ever done a Hello World program? Anybody done that? Anytime you take a programming language, that's the first program you learn to write. No matter whether you're taking Java, C++, we can do it in HTML. Did we ever do it in HTML? Ethan, did you take you took Dreamweaver, didn't you?
Yeah.
Did we do HTML? Did we do a Hello World in HTML?
I don't think we did.
We didn't?
No.
I probably started y'all right into the heavy stuff. No. All right, so W3 Schools is another one. And then this PDF right here is the other book that we'll use that's free. MindTap is not free. How many's bought their access code for MindTap? Anybody? Okay, good. Okay, good. But you will, the thing is, you won't have an excuse for being behind because there's 14 days free access to MindTap. So today you can log into it and start using it right now. It's your ebook and the lab that you use. So here's where you get the link. When you're in Canvas, right now you can do this. Click right here where it says, click here to access online textbook. So when you click here and you load access to a new window, it will look like this when you get into MindTap. First, you'll come to a screen that says access the trial or purchase it. You should see that first. Did everybody get there? Inside Canvas, right? It should be where it says click here to access the online textbook. So now here's the different ways that you can purchase the textbook. You can go to the bookstore and purchase an access code, and you can put that in at this link. Or you can purchase it direct online, and I've been told it's less expensive direct online than at the bookstore. So if you have the funds to do it, at the end of 2 weeks, you can do that. The Cengage offers something called Cengage Unlimited, which costs a little bit more than this class. If you buy it for just this class, it's $80. The access to the ebook and the lab. If you buy Cengage Unlimited, the reason that would be beneficial to you is if you have other classes that use a Cengage textbook. Like, how many of you are cybersecurity majors? Okay, you are. Okay, you will probably use more Cengage books. Therefore, you would want to buy the Cengage Unlimited for a year, and then you have access to all those books, which is a lot less expensive. How many engineering students? 3. Okay, and I'm not sure, you could find out, because you've got 2 weeks to decide which kind you want to purchase, if some of your teachers over there use Cengage books. And if they do, then even next semester, it would still benefit you to buy the unlimited. Okay, so you'll want to talk to your other professors in engineering or also in the gen ed classes. I'm not sure if they're using them or not. Ethan?
So it's using the MindTap course only, the one that's $80?
Yes.
Okay.
And then if you, let's see, what was the other students? Okay, multimedia. Ethan, is anybody else? Zachary, you're multimedia. So who else? Bree is. Anybody else multimedia? What were you, engineering?
No, I'm statistics with emphasis in math.
Statistics and math. Okay, so that's out of the math department or out of business?
It's some of the classes are in here, and then most of my classes will be at like the engineering and technology building. Okay.
All right. So, then they might use some Cengage books. Mm-hmm. So you may want the unlimited.
Yeah, that's what I'm doing.
Okay. So once you get in, even if you've just gone into the trial, and I realize my screen's really tiny, so you need to have it pulled up on yours if you want to be able to see it. I can enlarge my screen when I do. The resolution gets wacky over there. Oh, it's not going to let me do that here. I'd have to change the resolution. So within MindTap, what you see is only one unit of the book because I just gave you access to unit 1. Now, there are 7 units in the book. We are for sure covering 6. and it kind of depends how fast we go as to whether we get to 7, but we will do some of the concepts that are in 7 we will use in our final test. Now one thing, I did get to this, but I didn't go over. I went over the syllabus in Monday on that video. So if you have any questions after you watch that, ask me next time, okay? Or if you have any questions this time, I will look at it. But the pre-course assessment is something that you take and it doesn't count in your grade. It just kind of lets me know whether you have any background at all in logic or programming, okay? And so then up here, it says, welcome to your course, getting started. This shows you how to get around in this lab, MindTap. So that's what that is about. Then data files, you don't have to download these unless you want to do, there's some extra stuff that I don't assign that you can use those for. But then when we click on Unit 1, every chapter is going to be set up this way. There's a preview of the objectives of that chapter. This is where the one chapter of the book that we're on. If you wanted to see the whole book, there's a little blue icon over here that says full book. You can open that and it will show you the whole entire book. Okay, so you do have access to the whole book at once. I do this so that everybody doesn't get confused where we're at. These are little video clips that are very good. And on the Mondays video, you'll see that I show this one. We talk about flowcharts a little bit today. Okay, always there's this drop down and it'll have Python coding in it, which is what we're going to do in this class. But always we will do these coding ones together in class, but some students like to do them ahead if they know a little bit, and so they go ahead and do it. But if you get in there and you don't know what you're doing with it, we will do it in class. We won't get to it today. All right. Study section always has flashcards and slideshow, although I don't use the slideshow very much in class. It's a good review tool for you. And then the apply section will always have the test. And you notice in the email that I sent, there was a conflict in dates. Well, now the dates are identical that are in here and in Canvas. So when you take this Unit 1 test, and if you haven't didn't get to watch the Monday video because of my problem, what I let you do on all the tests that are in MindTap, you can take them as many times as you want to get 100%. If you're satisfied with 70%, then stop then. But I allow you to take those until you get the grade that you want, okay? Because what those tests are, tell me whether you read the chapter, okay? That's what those are kind of like, I call reading tests. And you will note there's 4 other tests. And because we do meet once a week, then you don't have to take them in a Zoom meeting. All those 4 tests will be administered on Wednesdays in this class when it's time. Like we have 4, so there'll be one at the end of 4 weeks. There'll be one at the end of 8 weeks. There'll be one at the end of 12, and then there'll be one at the end of the semester. And if in the syllabus, it explains that if you are here for all 4 of those tests, then you don't take the final unless you want to, unless one of your test grades were lower than you wanted and you want to try to get it higher. Because test 4 will cover the same things that the final does. Because this class is like when you take a math class, you have to know how to add before you can multiply, right? And you can't forget how to add when you get to multiplication. Well, it's the same way in programming logic. You have to know what we do in chapter 1. You have to still know what we do there to be able to do the problems that are in chapter 6. So if you're math people or engineering people, you're familiar with that kind of concept. It's not like a history class where if they give you a final, you have to go back and memorize all that stuff because you haven't been using it all the way forward. But in math, you keep using it. So that's how logic is. All right, so we are going to actually stay in MindTap today because we're going to look at the first chapter. And I know y'all are a little bit at a disadvantage because of I didn't give that correct video out there in time. And so what I had required students to do was to read this first before class and to take Unit 1 test. And you'll notice that I bumped the date up to August 26th for the test due date, Unit 1 test. So you have up until then to make whatever grade you want on the unit test, but you can go in right after you read chapter 1 and take it, okay? So the thing is with this, this chapter, we're going to go in, and it is also what I covered in the 930 class. So the Wednesday videos, you don't have to watch, only the Monday videos, okay? Or come into the meeting, because we're covering the same information, hopefully today, that I covered in my 930 class this morning, okay? So that's something too, except for I may not get to go as far because I know you all haven't read this material yet. But the way that the ebook works here is you saw the table of contents that I clicked on up here in this corner. If I want to get out of the book, there's always an X up here in the right-hand corner. And then I can go to one of these other areas. But if I click on the read, it's going to open it up across the screen, the whole book. Now, there's a, that's an edit. I don't know why that's up there. The chapter introduction is here. So it comes over and it gives me the objectives. I'm not going to read through those because that takes too long, but the chapter contents is always right there. So I can go back to it and click on it. So we're going to start with understanding computer systems. Now, how many in here have had Intro to Computers? Anybody in here had that class? What about micro applications? Anybody have Intro to Micro Application? The only reason I'm asking that is because this first part covers terminology. And so it's kind of an overview of computers and understanding the terms. Now, most of you all have probably always known what a computer was and always had some type of computer in your hand. When I was growing up in the 60s and 70s, we didn't have these yet. So I had to learn this. I got my degree in computer science in 79 is when I got my elementary education degree. Then I got, but my advantage is that my dad started in computer systems in 1955. So therefore, I've been around this terminology my whole entire life. So even though he used to bring home wired boards, that's the only way you could program. Now we get to program by typing in the keyboard. When I first started programming, it was on punch cards, and every line of code created a card. And so when I finished the program, I had a deck of cards about this high, and I didn't have a PC. There wasn't such thing as PCs yet. So this was over at UCO, which used to be Central State University. You would go in the lab and you would run your program, and you only had 3 chances to get it right because you only got 3 runs a night on a mainframe program. Now, here, you can run as many times as you want, and it'll even help you find out your error. I didn't have that advantage either. Okay, so I'm going to put this up a little bit. So computer systems actually consist of hardware and software. Who knows what the hardware is? Sebastian?
It's like the actual computer itself.
That's right, exactly. So, but this right here is no good to me without software. It doesn't do anything. It's just a piece of equipment. So there has to be somebody that gives this computer instructions for it to know what to do. And that's the software. And that's what we're going to be dealing with in this class, is giving the computer instructions to solve problems. Okay? And so the computer, I used to say to people, is only as smart as the computer programmer, because it can only do what the programmer tells it to do. And there's different kinds of software, and what we most often work with is called application software, which is like Microsoft Office. That's an application program. But if you talk about how we get this screen to print to that printer, that's a utility, which is part of system software. And we're not going to deal with that this semester. Just for you to know, these are the different types of operating systems, some of them Windows, which is what all these machines use. Then there's Linux and Unix and Google Android and Apple iOS for smartphones. And the reason it didn't mention OS X, which is what my Mac runs off of, is because it's a Linux-based system, okay? So those are types of software that I could not take what ran on a Mac and just put it over on a Windows machine and run it. But now I can, because Linux started using Intel processors. So that happened. But this book focuses on the logic used to write application software programs, although many of the concepts apply to both types of software. So now this is the important part. And that little video clip that I played on the Monday lecture, but I'm not going to play it in this class, but you can play it, that's outside MindTap there, goes over these three parts of every program. Has to have this. Has to have input, which is data that you put in. You can either use the hardware keyboard to put data in. You can use a mouse to put data in. You can when I first learned to program, you could not get data into a program with a keyboard. You had to use punch cards, and that's what fed data in. And then also you could use reel-to-reel tapes. Anybody ever seen pictures of those old kind of computer systems where you see these look like stackable washing machine, but it had in the door where it's open for a dryer, it had reels of tape. And that was after punch cards. They started using reel-to-reel tape. And that was pretty cool because you didn't have all that deck of cards. Then they went to what they called disc packs. And that really does look like a top-loading washing machine, but it was clear on top and you could see these disc packs that spun around. My first job was for the State Tax Commission downtown, or over where all the state office buildings are, and down in the basement, the whole thing was full of reel-to-reels and disc packs. And up on our desk, we just had an old monitor, but it wasn't color, it was green bar. And it was hard on your eyes. But we typed onto there, which fed into those computers down in the basement. But when I went to school to learn that language, they were still using punch cards. Okay, so we have input, some way to get data into our computer. Then we have processing steps, which are processed by the brains of the computer or the central processing unit, which is sometimes referred to with the acronym CPU. Does this have a CPU? Yes. Every computer, no matter how tiny it is, has to have a brain. It just has to. So when I started, they were humongous. They didn't have little bitty tiny CPUs like they do now. So every device has a CPU. And so that is the processing step. So that's what we take our data, whether it's numbers or whether it's alpha characters, and we feed it into the processing or the memory of it. And then we output information. Now, originally, the only way to output was on paper. And when I started programming, it was big, wide green bar paper that came out of the printer in rolls and rolls. And it was on and then it was perforated where you could tear off sheets. But it was an old dot matrix printer, and that's how it worked. And now we don't have anything like that. So that was how it printed, and you didn't have anything to the screen. Well, in Python, we're going to do everything output to the screen. We're going to get our results on the screen. Before today's over, we're going to write that little hello world back to the screen. So you write computer instructions in a computer programming language, such as Visual Basic, C#, C++, or Java. Those are a special type of language, which was all they used to have. They didn't have anything called scripting languages, which is what Python is, and it's a lot easier to use, and you don't have to do a compiler. So we have program code, which you would think were the instructions that the computer reads. But it can't read Python. What does a computer read? Zeros and ones. Awesome. I have some engineers in here. Okay, so zeros and ones are all that our computer can actually read. Well, we don't want to have to program in zeros and ones. So we use what's called high-level languages. And even though they're a language that you have to learn the syntax, just like when you learn a foreign language, you have to learn the syntax. What's the syntax? What's syntax in English? Almost told you. Well, it's the grammar that you have to learn. Like you have to learn where a period goes and where a comma goes, right? In English, well, you have to learn that in every language. So every language, whether it's Java, C++, whether it's Python, they all have their unique syntax rules. Okay, so we're not going to worry so much about that. We'll learn a little bit of Python syntax on the way, but we're going to be interested in this class of how to logically solve a word problem. You probably hated those in elementary school, right? Okay, we're going to learn the easy way to do it. We're going to pull out just what we need in those word problems or those business problems to solve them. Okay, and engineering, it's a little bit different than business problems, but the logic is the same. Okay, so here is some of the examples of syntax in different languages, but we're going to do a Python hello program here in a little bit. Okay, so in the computer, there's memory that goes away and memory that is permanent or actually there is some memory that's permanent called ROM, but we're not going to talk about that. But when the first computer PCs that were used did not have hard drives like your C drive that you store information on. What's another permanent storage device? Yes. Thumb drive, is that what you said? Thumb drive, yes. CDs, any of those are storage devices that are permanent. But when they say volatile and non-volatile, volatile is when you execute a program or run a program, it goes into computer memory. And if you shut the computer off right then and you don't save it, then you turn the computer back on, whatever was in memory is gone. Only what you stored on the hard drive is still there or on a thumb drive. Or now we have other storage. What do we use the most now instead of thumb drives? We use the cloud. And that is really has changed how we use our devices because we can store information in the cloud and access it here, here, here. As long as you have access to the internet, you can access whatever you save to cloud storage. So like I use iCloud because I've had a Mac since 2006. So I use iCloud. But now Google, your email, your Raider email is a Google email address. So you probably have other Gmail, but your Raider is the one that we're going to use in here. Well, with that Raider account, you have free Google Drive storage. Therefore, when you're working on something in class and you save it on the C drive, I would always save it either on a thumb drive or on Google Drive or whatever virtual storage you use, whether it's Dropbox, that's another one that you can use. Because if they ever have one of these crash, then they have to re-image them. And so whatever you stored on the C drive is no longer there, okay? So if you use these in the classroom instead of a laptop of your own, then you will need to store either on Google Drive, which is connected in Canvas. You can actually get straight to your Google Drive that way. Also, you have a YouTube channel connected to your Raider account. You have everything that you have with a Gmail account with your Raider account. Google Docs, all of those. So those are things that you can use as part of your Raider account and not get it confused with your personal Gmail, okay? Or your personal YouTube if you want to use it. Okay, this talks a little bit about, now I'm going to let you go back and read this, but we don't deal with machine language programming in this course. But if you were a computer programming major, then you would take Java and you would take some of those different languages. And used to, cybersecurity people had to take Java and advanced Java, but now they've gone to script programming. Python is what they use mostly. All right, so here it talks about the scripting languages. In web design, we use more JavaScript than we do Python, but Python is a little easier. So if it's easier to use in this class than to show you how to use JavaScript. And if you learn the logic behind scripting, then you'll be able to pick up JavaScript for web design. We did a little bit of it in, did we in web design? Zachary, did you take Dreamweaver yet? Web design, Dreamweaver? Okay, so we actually didn't code in JavaScript, but we used some JavaScript code and put it into our program. Okay. So scripting is what we're going to do. Now, along the way, we're not going to take time right now to go through these, but the answers are right there, and it just covers what you did what we just went over there. Because I want to have time to do some other stuff. I played this in the 9:30. I'm not going to right now because I want to have time to do some other stuff. And all along the way, there are these little video clips in the ebook that are done by the author of the book. And so she just goes over and covers what she covers in the reading material. So it is a little better explanation. Sometimes she talks about input, processing, and output in this one, the introduction to a simple program. She also shows you pseudocode and flowchart and a command line, what it would look like. So we're going to do that too. All right, so here, you might think that programming is just all logic. It has to do with programming code, but everything you do every day has logical steps that you do without thinking about it. But this one is showing you, like if you were baking a cake, get a bowl, stir, add 2 eggs, add a gallon of gasoline. Oops, that would cause a problem, wouldn't it? Bake at 350 degrees, add 3 cups of flour. Okay, it tells you, don't do this. This is called the logic. If you get things out of order or you put something in that doesn't belong in your program, in your instructions, that's called a logic error. The syntax errors are the easier ones to find because that's just where you put a semicolon, left it out, or you left out, you misspelled a variable name or something like that. So here is pseudocode that has 3 steps. This is our input, this is our processing step, and this is our output. And so pseudocode, this won't run in any language, even in Python. This is just called pseudocode because I can put each one of these statements into Python code and then it will run. But right here, like the word input is not used in Python. The word output is, and it's called print in Python. But these are things, when you're writing pseudocode, the purpose of it is that you can take any language, and if you've solved it in pseudocode, solve the problem, then you can go and put it in any language, just so you know the logic, okay? You can write this, I can show you all the 3 different ways. So it's the logic. So what this one does, this instruction says to input my number is an example of an input operation. My number is a variable name. So what does variable mean? What does the word variable mean? Just logically, what's the definition of vary? Change. It can change. So when we come up with a variable name, it means that this is a placeholder for a value. And one time I run the program, the variable might have the value of 3. The next time I might ask the user for what do you want my number to be, and they might put 5. So let's say if we were working this and this problem was, let me go down here. Okay, this problem, you said input my number, and the user put in, oops, this is supposed to be capital, and the user put in a 3. Okay, if I took the 3 and I multiplied it by 2, what would my answer be? 6. Not trick question. You were right. My answer would equal 6. Okay, say the next time. So that's a variable name too, because it's going to change dependent upon what my number is, right? So what if I ask the user, I say, okay, what's my number this time? What number? What one we want to pick? 4. Okay, so we're going to make my number 4. So if my number's 4, what's my answer then? 8. Okay? See how easy that is? You're a programmer already. See? You understand code, and you thought you couldn't. Okay, so that is what the problem for this ask is. It says, take a number, multiply it, double it, and print it out. That's what the problem is that you just solved. Okay, so we're going to see that work in Python here in just a second. Okay, so now what is different about this line versus how you learned to do it in grade school? How did you write that? Even if you were using variables, what's different about that? Did you used to do it this way? Is that how you used to do it? Yeah. Okay. The computer understands it opposite, because what that equal sign is sometimes referred to is an assignment statement. It's whenever you want it to compare two sides, you have to use a double equals, but we don't in pseudocode. We'll get to that later. Don't worry about that. Okay, so what it's saying is take everything that's on the right-hand side, and whatever the result is, dump it into this variable. That's what that assign, that's why it's called assign. Assign what's over here to this variable. Okay, so it's backwards. So you don't want to write it like this because the computer won't understand it. It'll do something different. All right, so here is our output. Now here's something else. Why did I make this to be lowercase and uppercase like that? Why did I do that? Anybody read ahead? A variable cannot have a space in it. So when I name a variable, and we don't get to that right there, but when I name a variable, I could have written it just like without the uppercase. I could have said my number, and it would have done the same thing as long as I use that both places. But this, oh, that mess, autocorrect. Quit doing that. Okay, so this is not the same as this. So if I use it this way without the uppercase, and then down here I change it, it won't know what I'm talking about down here. It'll say, what? I don't have anything in there. Because the case, whenever it says that a language is case sensitive, it means that it cares which letters you capitalize and which ones you don't. But If you decide that you don't want any of your variable names to have capital letters, it'll work. You've just got to always remember that. So what I always tell students is to develop a naming standard that you're going to use always, because some students prefer this, mine underscore number. You can use an underscore, and you can sometimes use a dash or a hyphen, but most people don't like that. So if you rather see blank spaces, then you can do an underscore, okay? But if you do that, I would suggest that you always name your variables that way so that you don't get confused in a real long program and forget how you've named it, and the next time name it this way, okay? Because it's going to be a different variable. Yes, Ethan.
So the program doesn't matter what you use as long as it's all the exact same?
Exactly. As long as you're consistent, you can do whichever method that you want, okay? So if I like underscores, then I can do underscores. If I like camel casing, that's what this is called, then I can use that. And what's really made it hard for students is because they've gotten used to Microsoft Word and DOS and all the Windows stuff, and they let you, when you say save, they save your file name with spaces all in it and words. Well, when you try to upload that to the web or to internet, it won't leave those spaces there. It turns those spaces into percent signs. It puts it, because it doesn't recognize a space, and it has to have something in there. And so that's what it does. So you're better off not to ever use a space, because then you'll be trying to access a file or a variable and it has a percent sign in there, and you don't even sometimes see it, but that's how underneath the code that it interprets it, okay? So that's why you can't ever use spaces. And you'll probably forget. That's okay, I do too. So that's one thing to try to see. Like now, when I even save Word documents, I don't ever put spaces in it, because then I'm consistent across the board. Even though Word would let me do that, and DOS would let you do that, if you try to take that file and upload it to the internet is a Unix-based system, and it doesn't like that, okay? All right, so these are I want you to go ahead and read the rest of the chapter and take the unit test, and we'll talk some about this in the Monday lecture that you'll watch. But here's what I want you to do right now, because I know you guys that didn't watch the lecture over in and it's my fault here in Canvas, there's a link to Lucidchart, which is the flowchart tool that we're going to use. And since you can't see this up here, if you go back to Canvas, or you can go to another tab and just type in lucidchart.com, and you spell it LUCIDCHART, no spaces.com. And you're going to create a free account, and we're going to create our first flowchart. So when you go to there, let me log out. So when you go to there, you're going to see this, and you'll put in your row state email address, your rater email address, and then you'll click next, and it will let you have a free account. You'll create your password. Once you get it, this will come up. And now we're going to create a blank document. So up here where it says, you won't have all of these. This is because I've used Lucidchart a lot. Here's, you add here, and it will give you a grid. And then the tools across the top look like Microsoft, except for they have a few extras like line options. These over here are what we're going to be using, these shapes right here. So that little pseudocode that we just did in the book, we're going to use it, and then we'll do a hello program pretty easy. But first we're going to do this one. So if you want to do your pseudocode in here also, where that everything's on one document, and since we already saw the pseudocode, we're going to do it first. So we're going to pull this little text box over here. Okay. And you can stretch it. You graphics people, you'll know how to do all this. Then you click this and you can align it up to the top left, which is what I like to do. And then I like to make my text about 18. You don't have to make yours that big because you're not trying to have students see it. You can leave it at 12, 8, whatever you want. Then I'm going to click over this. And the way I start, is everybody all right? If not, you can go back and watch this in slow motion. Okay, and I do it in my 930 class also. So here I'm going to put start because every pseudocode is going to have a start and a stop. But then I go return and I'm going to indent the middle part. So you remember in my book, it said input, and I'm going to do it just like the one in the book. If you want to name your variable differently, you can. But I'm going to name this one, and I'm going to make my block a little bigger so it doesn't jump down on me. Okay, input my number. Oops. And then, oh, that wasn't what I wanted to do. No. Okay, so what I want to do next is go down here, tab over. The next statement was my answer equals my number times 2. What I was trying to get it to do was to pull out. There we go. All right, so the last thing that was in the book was to output my answer. And then, like I told you, every pseudocode, stop. And some of them you'll see start and end or beginning and end. Pseudocode doesn't matter because it is not going to be put into a language. But this is how we solve a word problem that says ask for a number from the user, double it, and then output the result. That's the pseudocode for that. Now, we're going to do the flow chart. Every flow chart is going to have a start, which is going to be these that are called terminator, these little ellipses. And once I pull that out, I can pull my other shapes from here. But the easier thing is to see this little dot here. You click on it and it gives you an arrow down that connects to a parallelogram. All input and output are always in a parallelogram. And if you don't remember your geometry, it will actually give you a tooltip over here that tells you that's for process. And where's my data one? There's the data one, okay? So I'm gonna pick that one for data. There it is. And then I put all my shapes in before I put my text in here. So the next step is my processing step. So it's a rectangle. And then I need output, which is going to be another parallelogram. Like I said, if I'm going too fast, you can go back and do it. But you won't turn this in anyway. This is for practice. Everybody stopped, right? Okay. So this one, the last one, is the terminator. So I'm going to put a terminator there for the stop. So the start and the stop are the same symbol. The input and the output are the same symbol. Okay. Now up here where it says terminator, I'm going to change it to the word start. And I'm going to change my text again a little bit bigger. Let's see. It's going to make me do that before. Something like that. So in here, what goes in here? My input statement. So it's going to say input. I can actually just copy it. Number. Okay, and that maybe needs to be a little bit bigger. So I'll make it like about, maybe it'll stay in there if I do it there. So what do you think goes here? Yeah, my answer. So I can either copy it from my pseudocode or I can put my answer equals my number times 2. And if I want to stretch my box, I can. Then it makes my lines a little wacky, and I have to come back. Okay, then here is my output. So it says output my answer. Now, if you changed your variable names and didn't do them like that, then you need to be sure that you do them the same. They should be the same here as here. And the last thing I do is my stop. Now, every time I have you all do a problem, I'll have you do the pseudocode and the flowchart, even though it says flowchart or pseudocode. I always want you to do those two up until after test 1. Then I'm going to let you have the option. Because some people prefer the picture. It makes more sense to them. Some people prefer the pseudocode. But we need to learn to do both, and then you can pick which you like. Okay, so when you get ready to turn this in to me, you go up here to File, which remember, I don't want this one, but this is so when your homework assignment. So File, and it says Download As. Doesn't say Save. It says Save up at the top, but if you do Save, it'll just save it as a lucid chart object. So when you're ready to save it, I want Download As PDF. Okay, and then over here, it's going to say Download, and then it gives me the option to name it. So whatever I usually like, this is example 1. So I'm going to call it example 1 and my initials. I usually have you put your initials. Then I'm going to save it for my class here. So I'll say save. And now it's saved as a PDF, and I can submit that in my submit assignment in Canvas. Okay? So you have to remember where you save it. So now if I open that, here's what it looks like. That's what I created in Lucidchart, right? Oops, where's my Lucidchart? There it is. Okay, so now I want to take this and I want to make it into a Python program. Yes?
Where is that again, the download button?
Download button? Okay, go to File and then Download As. Oh, I'm sorry. Yours says export?
Yeah.
Wow, that's weird. It must be a different version of Lucidchart.
Yeah.
Okay, export and then PDF. I'm sorry about that. And then you should be able to. Wonder how that's a different version. Are you on Google Chrome? Well, I'm going to figure that out. I don't know why it's like that. Because that's internet. That shouldn't be the version of that. Unless your Google Chrome isn't. I don't know. Okay. So we all got there now. Okay, so now what we're going to do is on your Windows PC, and I probably should go over to Windows now. Is everybody on Windows? Yeah, okay. So I'm going to switch over. Let me switch my thing over here. Oh, I think it makes me get up and do it. So let me get this logged on first. And then I'll go to this and you'll be able to see it better, know what I'm doing better. Okay. Wilson and okay. So okay, so now to get to Python, you would go here to your start button and scroll down to where it says Python 3.7. Okay, click on that. And we're going to use idle today. It's an editor for Python. And one of the in the assignments, the guy who does the tutorials that I have you do, he uses what's called PyCharm, which is going to be on here too somewhere. I don't know where. I'll have to look for it. But anyway, idle is what we're going to use today. So click on idle. and mine's already set up. So yours won't look like this. So you have to go over to options, go to configure idle. You see that? Okay.
Where'd you go for that again?
Okay, the Python or the idle part.
Just like, yeah, this version.
Okay, go down here and go down to Python right here and click the down and then click idle. And then we're going to get into the editor window where it's a blank screen. And so to do that, you've got to go options, configure idle, general, and click on open edit window. Yours should be defaulted to open shell window, right? Open edit window. And then down here, click apply and click OK. And now you'll have to close your window and then open it again. And it'll open like mine, blank. So go here, here, and idle. I see PyCharm. It's right here. So we'll use it next time. Okay, so now if you can see your pseudocode, or you can look in the book if you can flip back and forth, but if you know it in your head because it's a real short one, then you won't have any problems. So here we're going to do this in Python, and we're going to type it in, but in Python, you're not supposed to know this yet. I'm just going to tell you how to do it. In Python, we want the user to enter a number. So we're going to say my number equals input, and in Python, you would say, please, or whatever, however you want to say it. You don't have to say please. I do it myself. Please enter a number. And you have to put it in quotes, and you have to put it in parentheses. If you can't see that, let me see if I can format it a little larger. I can. Well, maybe you can see that. Let me see if it'll. I thought it was that way. Oh, I know what it probably is. That's not the font. Probably is this. Let me see. Where's, no, that isn't letting me bring it up. Well, if you can't, I'll try to get it larger next time. Okay, my number equals input. Do you guys see it back there? Ethan, can you see it?
It's hard to see with the green, but
You know what I put in?
yeah.
Okay. All right. So next, what you do in Python is the my answer is actually typed in, oops, just like it is in the book. And Python will take it just like that. My answer equals my number, and you can put a space or you don't have to. Python doesn't care. And then you would put print, and then in parentheses, you would put the name of the variable, which is my answer. And you don't put it in quotes because you don't want it. If you put it in quotes, and we'll go back and do that if we have time, then it would just print my answer. It wouldn't print what the value of it is. So now we're ready to run it. So you go up here to run, and see where it says run module. Don't do Python shell, do run module, and you'll notice the shortcut is F5. So it says source must be saved. So say, okay, I want to save it. And so I can put it anywhere there, the name of it. So I called it example 1 DW, and it will put Python. Oops, I didn't put my E in there. I do it right. So now I click save, and then it runs it. And you notice it says, please enter a number. So I can enter a number I want. I'm going to enter a 5. You can enter whatever number you want. Hit the enter key, and it gave me 55. Is that right? No. Why is that not right? Anybody know? Python, you know what it did? It just typed 5 2 times next to each other because it doesn't know that my variable is a number. So I have to convert it. I have to tell it that it's a number. That's something that I have to do. It's called an integer. So here's what I have to do. I have to say int inside here. There's 2 ways I can do it. When I do that, I got to put a, wait, let me put it back here. There it is. So now let me see what happens when I run it. Let's run again. Save, yes. Oops, gave me an error. I have to put, I think I put the int in the wrong place. The int goes outside here. Just a second. Actually, I'm gonna do it different. Here's the way that might make more sense. Okay, my number is a character, even though it does, I know that I entered a number. So I'm gonna say my number equals int my number. So now it's going to take my number and change it to an integer so that when it does the calculation, it'll be an integer. Just a second. What's your question?
I can't see it and I figured out how to make it larger.
You did? Okay.
Yeah.
Oh,
You
okay.
just go to configure idle and then the first page on the font, you can change the size and put it black.
Right here, configure idle. Oh, here's where the font
The
is.
size is down there right in the middle.
Right here?
Yeah.
Okay, let's do 20. That'll be really big, but that's okay. Okay, so there you go. Can you see it now? Okay, so what that's doing now when I run it, I'll run it. Let me move this over so you can see it. It said, oh, it won't let me. Please enter a number. So if I enter 6, now it gives me 12. So it's doing the right answer now, right? So what it did before is it took 5 as a character, which means like in an address, if you give 1208 your house number, you don't want anybody to use that to calculate with. And that's how Python takes in anything that you input from the screen as a character. So you always have to convert it to an integer, or later we'll do a float, which has a decimal point. Okay, so now let me show you real quick. I know it's time to go, but let me do, I'm going to do one new file. I'll create a new one. If we were going to do hello world, it's the most simple. All I have to do is say print. It doesn't have input and output, right? So now if I run this one, run it, save it, okay. I will call it my hello one. Hello world. So you can write print statements over and over. And does anybody need that other one that I, let's see if I do that one. There's that one. Which one, the first one, is that what it is? Okay, show me your program. Okay, so you did, oh, that's because that says my input instead of my number. Yeah, right here, you've got my input. And it just says, it should say input. See right there? See where mine says input? And on the top line. The first one, you didn't use the Python command.
Oh, okay.
You put the variable there.
Okay.
Now try it.
And on the other screen, it's still showing trace back.
Okay, let me see what else you did.
Okay, my answer. Got it.
Yeah. So it didn't. Oh, you got a capital line. See, the way you can tell it's wrong is because that was a python and it wasn't in pink.
Okay. There.
There you go. And remember.
Thank
Okay. We are done for today. And oh, let me show you though what I showed on the other class. Down here in there's your Unit 1 test. This little problem here is one that is at the end of Chapter 1, and it's not due till September 2nd, but some students like to work ahead. That's at the end in MindTap. You remember I told you here you can get to the exercises, and this is also on the other video. Down here is where that problem is, where it says programming exercises. I have you do 2 and 6, but we're going to do some of these in class on Monday, so you'll want to watch that video, okay? And then the other thing that's here, that's due the 2nd, we'll do this in class, but the 2nd, this is the guy that I was telling you that I have you all watch, and he tells you how to install Python on your home computer so that you can do all these at home. And he uses PyCharm instead of idle, which does the same thing as the idle. It's an editor that lets you type your code in, okay? So I know this isn't due, but if you want to see some more about you like the Python, this guy goes through step-by-step. Here's the setup in the Hello World program and those things. So that's all in, and I will cover some of that in the Monday lecture, okay? All right. See you guys on Wednesday. If you need something, be sure and Zoom or email me, and we can set up a Zoom meeting during office hours, whatever, okay? All right. Y'all have a great weekend.